Kitchen chemistry, dry ice. Now, whatever the experiment you do before this is, a good segue into this experiment is, did you think that last experiment was cool? The kids usually say, yeah, or yay, or wee. And I say, did you think that last experiment was cool? And they go, yeah. And I say, you want to see something cooler? Yeah. You want to see something cooler? Yeah. It's my cooler. Thank you. Okay, so I know my cooler isn't very cool, but what's inside my cooler is pretty cold. It's actually minus 79 degrees Celsius. It is too cold for me to touch, so I have to put on the gloves. So here I have 2 leather gloves. It's got to be leather. Can't be garden gloves or latex gloves because the coldness will go right through. So they got to be thick leather gloves. Now every once in a while I will by accidentally pack 2 left-handed gloves. Now when that happens, just continue to talk and see if anybody notices that you actually have 2 left hands. And then when you notice, ah! Okay. All right, so now who can tell me what's inside the cooler? Now some of the students have already seen dry ice. So they'll say dry ice. And you'll say, awesome! Usually call that student up and ask them the question, what makes dry ice dry? And they'll be like, I don't know. Or they'll say, because it doesn't become a liquid. Either way, you say, awesome. Let's figure it out. Here we go. Everyone say solid. And have the camper next to you dance with you. Say solid. Then dance a little bit. Liquid. And gas. Now they have to do the same thing. Now this stuff doesn't go through that. Water will be a solid ice. It'll melt to become a liquid and it'll evaporate to become a gas. This actually never melts and doesn't evaporate. It goes straight from a solid to a gas. Straight from a solid to a gas. So we call that sublimation. Everybody say sublimation! Sublimation! Then, all right, we're going to bring it out. Now remember, it is too cold to touch. So if I happen to drop it, don't pick it up and go, ah! Don't do that. Okay, so here we go. We're going to bring it out. So this, you can see the 2 states of matter. I can see the solid ice and the gas coming off. Do you know the name of this gas? Some students will know the name of the gas. It is actually carbon dioxide. So I say carbon, you say dioxide. Carbon dioxide. Carbon dioxide. I say carbon, you say dioxide. Carbon dioxide. So we can see the dioxide gas is coming off of here. Now it's all carbon dioxide gas. But this is actually in gas form, this is in solid form. So we can see it coming off here. Now, pop quiz. Who was the first president of the United States? George Washington. What river did he cross during the Revolutionary War? The Delaware. Was it cold or hot that day? It was cold. You ever see the painting with George Washington on the boat with his horse? There's actually ice in the water. So here, to this day, Mr. George Washington shivers. Now I ask the campers, what makes him shiver? And they say, because he's cold. Right. When you jump in a pool, you go, ee! That's exactly the same thing. But he has no feelings. He's a quarter. You have no feelings. You don't. Stop it. Now here, it's actually because this is a room temperature quarter. And this is very cold dry ice. So to the dry ice, this is extraordinarily hot. So it makes it sublimate or change from a solid to a gas really, really fast. So if I take the quarter, put it inside there, the sublimation or the gas will actually push it back and forth. Now what made him stop? Because he was in the dry ice already, he got so cold that it stopped making it sublimate. It's still sublimating, but not to the point where it pushes the coin back and forth. So I could hand this to a camper, have them hold it, warm it back up, and then put it back in and watch it sublimate or go back and forth again because it's sublimated. So that is the George Washington bit of dry ice. Now, we say, okay, we saw what happens if you take a coin and put it in dry ice. I should tell you also, too, that my dry ice has learned how to sing. Here I have a regular metal spoon, and I have my dry ice, and he's going to sing whatever. Oh, that's horrible. Okay. Thank you, thank you, thank you, thank you, thank you, thank you. All right, so what made the spoon screech? Sublimation again, because the spoon seems really, really hot, and this is very, very cold. It actually makes it turn into a gas so fast that it vibrates the spoon, and that vibration makes the sound. So that is the singing dry ice bit. Now you could also do this, where you take a little bit of water, and you say, how much time does it take for water to freeze in your freezer? The answer is usually about 2 hours, depending on the freezer. So here, if I take water and I put it on dry ice, how much time does it take? Now at this point, I usually walk around and I do this. Now make sure they don't touch the dry ice. And I put it on there, and I see how long it takes for the water to freeze, and it does stop making the noise after a little bit once the spoon starts to cool off. And it's usually about 30 seconds. So I'll have the kids start counting 1, 1,000, 2, 1,000, as they observe the liquid turning into a solid. Now you see all three states of matter. You see liquid water, you see frozen water, and you see the gas of the carbon dioxide. So all three states are happening right here. And a lot of times I'll leave a little bit of extra water there just to splash the kids. And say, oh look, it's frozen. There you go. And then they can touch this because it's just regular ice with their finger. That is the frozen water part of dry ice. Now, I take the dry ice and I say, okay, so now I have the dry ice. What would happen if I take the dry ice and I put it in warmer hot water? Oh, that's not going to work. I did set up this piece ahead of time. I call it my demo piece. So I find a bigger piece. I usually break this up by hitting against the ground before I put it in here. Also, you never want to put dry ice in the refrigerator because that moving air will make it sublimate faster. You want to keep it in a cooler with newspaper or plastic over top. Now, if I take a little bit of dry ice and I put it in here, there we go. So now we can see it sublimating even faster. And you can see it happening right now. It's sublimating because of the hot water. And this is actually how they do those effects in movies. It's working! It's working! Okay. Now here, if I take the cork, I can show you that I have superhuman strength. Now this gas is expanding. Everyone say, expand! Now when it's freezing or being frozen, it actually contracts. Everyone say contract. Everyone say expand, contract, expand, contract. So now, jazz hands. If I take this, put it on there, I could bring a camper up and say, have you ever had soda before? You ever noticed that there's bubbles in soda? Do you know what the bubbles are made out of? Carbon dioxide, the same gas that makes dry ice. Do you ever taste the soda without the syrup and the sugar and everything that makes it taste good? No? Well here's your chance. This is the bubbles in the soda without everything in it. So you go like this, make it, make a little bit of gas, come out like this. They stick out their tongue, doesn't taste like anything. Right. What happens here is this is actually called a burp. You just tasted a burp. Right, when you drink it soda fast, it builds up carbon dioxide, that's a burp. Okay, so here, but what I can do is show you my superhuman strength. This gas is actually pretty powerful. It actually would like to, hold on to the, push the, oh. Okay, let's try that again. What happens is gas expands, and as it expands, it takes up space. Everyone say gas takes up space, and as it does it, now this is actually how a steam train works. So a steam train boils the water. As the water boils, it takes up space and starts getting the train to go. Woo-woo! Same thing here. Imagine this is a piston. This will actually push it out because it has a lot of pressure. Okay. So now, we also have boo bubbles. Boo bubbles is optional. If you have a lot of time and you want to do boo bubbles, you can actually take your dry ice, put it inside here, then you get a cup with some Dawn soap. You put that in the cup and you'll have big cool bubbles coming out filled with carbon dioxide. But if you don't have a lot of time, you can just move on to the bucket. Now here, we're going to see what happens if we take dry ice and put a little bit of water. What happens if we put in a whole lot of water? Put on our safety gloves, safety first. We're going to get our dry ice. Now at this point I can put my demo piece in. Should I put more in? Yeah! Okay. Should I put more in? Should I put more in? Yeah! No, you're crazy. Okay, so now here, we have this. Now if you observe the gas is bubbling up. Which way is it going? Now if you're really observing, you'll see some of the gas is going up, mainly because we have fans on in the room. But it's actually going down. That means the gas is heavier than the air around it. So this gas has mass. Everyone say gas has mass. Good. All right, so the gas has mass. Now, I'll call up a camper and I'll say, can you take some of this and pour it in there? Now while they're taking some of this and pouring over there, I'm going to pretend like I'm not paying attention. But like you pour in there, and I'll come over here, and I'll try and find a good piece of dry ice. Now at this point, I'm not paying attention because they're going to observe something, and I'm going to pretend like I don't know what's happening. So they're pouring in the soap, and it really doesn't matter how much soap they pour it in. Hopefully it's not the whole thing, but who cares if it is. So they pour it in there. I'm still looking for the dry ice, and I'm still talking about how dry ice is solid and how when it goes from solid to a gas, it does sublimate. So we're actually watching it sublimate here. Now, if gas were to take up space, that's how balloons get bigger. That's also how bubbles are created. So if I'm over here, now at this point you hear the kids start screaming. I'm like, I'm sorry, I'm talking. And then, would you please? I'm trying to, and then they're screaming because of the bubbles coming over this way. So ignore them until you go, what? Why didn't you tell me? Now the bubbles are going everywhere. Pretend like you have to do something with the bubbles. Okay, I forgot to tell you I'm allergic to I'm allergic to And now, of course, this is where the kids go crazy, and you have to give a safety warning. Please, everyone, sit down. Crisscross applesauce pretzel legs. Do not lose your minds, or else I will not sneeze on you. If you do want to be sneezed on, you'll have a seat. Surprisingly, they sit. So you walk around, and you go, and you do that to all the campers. Make sure you sneeze on them. You can also bring up a camper, usually a girl, and say, who would like to be Elsa, the Snow Queen? And they come up and you say, do you want to build a snowman? And place that on their head, and there you go. It's a timeless classic. All right, and that is pretty much it for dry ice.